Okay, so this is the review for exam 2. So I'm going to start out by first talking a little bit about the format and the administrative stuff for exam 2. Then I'm going to go through the solutions for homework 1, which have already been posted. And then I'm going to do a couple of examples of the more mathematically problems from homework 2. I'm not going to do this exact questions because it's due tonight, but I'm going to do examples like the 2 calculating questions. And then I'm happy to answer any other questions you have about homework 2 or any of the other materials. So that's sort of going to be my agenda walking through this. And if at any time you have a question, throw it over in the chat or pop on with your microphone. If you do throw it in the chat and I don't see it because I'm screen sharing, just give one of these little claps or something like that so that I can, I'll see that pop up on the screen probably. Or just pop on your microphone and say, hey, I have a question in the chat, either way. All right, so let me do a screen share over to Canvas here. And share. All right, are you guys seeing my Canvas? Because it's showing me a different screen, but I think, so somebody let me know if you're seeing Canvas. Oh, I don't see the chat now. Yes, okay. Yeah, that's one of the weird things Zoom does. When you go to share a screen, it hides the chat and all the participants. So you have to reopen those windows when you share. And if you unshare and then share again, you have to reopen them. It's very annoying. All right, so I got a thumbs up there. So you're seeing my Canvas over here. So I'm just going to go into our Canvas. And what I did is I posted exam, what did I put it under? Assignments, maybe? Where did I put it? Oh, quizzes, that's right, because it's timed. All right, and so I put a practice version of the exam here so that you could practice the steps of what it's going to be like in the real exam. Now, there's 2 questions on there. They're just made up. They're nonsense. But I would highly encourage you to go into this and practice it. So I'm going to put myself in student mode. And unfortunately, even in student mode, this is one of those situations where the student view doesn't exactly show me what you guys will see, but it'll be close. Here is the, and maybe I should put this on the modules page. So let me drop out here real quick. And because sometimes people, you guys are pretty good with Canvas. In my other class, I've got some, freshmen, like they've never even been on campus yet, and they're taking principles of micro, and they don't know how to use Canvas, so sometimes they have a hard time finding things. Sometimes they don't even know what they're looking for, and so that can be a challenge. But you guys probably know where to look for things, but just in case, I'm going to put this right on the modules page, published, so you guys can find it more easily. Now let me go back and put myself in student view. And so this is the modules page in student view. I just put that exams up here. It's also under quizzes. This is where your exam will appear right here. It also appears, you have these to-do lists that appear throughout Canvas. Some of you may have customized your Canvas views, so they show up in different places depending on what you've done. But if you haven't customized anything, they usually appear right over here on the right-hand side. So if you go into this practice, so it says, this is a practice exam. So this is where the instructions for your exam will be. You're going to have 2.5 hours from the time you hit start, until you have to upload your final PDF. All right. right? And on the real exam, there's going to be instructions here on the same instructions that appeared on the announcement that I sent out the other day. So this announcement, Exam1 details, I put all of this information about how you can download the exam and then prepare it in whatever way you're most comfortable with. But at the end of the day, you have to submit back to me a PDF file. So you can print it out, the exam, and write on it, and then scan that. And here I give you a couple of examples of apps that do a really, I mean, you just click each page and it undistorts the page, makes it look great. I use the Evernote one, but there's a bunch of them out there, and it makes it a PDF, and then you can email that to yourself and then upload it. You also, some of you may have printers that have scanners on them. You can even just take pictures like on your phone and then pull those into something like Preview on the Mac. I don't know how you do this on Windows, so you might want to investigate that. You could pull those images into Word or into Pages or into Google Docs and then make that a PDF. Whatever way is most comfortable for you to do it. Some of you may want to download the PDF, open it in Google Docs, which will open the PDF and make it editable, and just put your answers right below. And then any graphs or images, you can paste them in that way. I'm leaving this completely freeform. There's only a few of you in the class, so I know I'm going to get a bunch of exams that look very different from one another. And normally in a big class, that's a pain when it comes to grading. But there's so few of you guys, and we're under kind of unusual situation here. I want to give you freedom to do it however you, whatever technology you know and are most comfortable with. If you're not, then read through these examples I give and practice this. All right? Even if you are, I would suggest doing the practice. So this information will also appear at the top of the real exam for quick reference. So when you're ready to take the exam, you'll have 2.5 hours. You can take it anytime during the day tomorrow. So I think what I said in the announcement is that you have, it'll be available at 12:01 a.m. and you've got to turn it in by 11:59. And I usually put 15 minutes of kind of a grace period there, just in case you go to upload the PDF and it takes forever or whatever it is. But once you hit start, you only have 2.5 hours, all right? Now I'm writing this, it's the same exam I would give to a 75-minute class. So I write it for 60 minutes, all right? You have 75 in a normal class that meets, all right? Plus usually I can give some extra time for in between the breaks. But I'm giving you 2.5 hours because it can take time to get all the technical aspects of this correct in terms of downloading it, editing it however you want, recompiling it into a PDF and uploading it. That may take some time. So, you know, a good idea would be, you know, give yourself 2 hours max and then give yourself at least 30 minutes to get it uploaded, just in case you run into any problems. I don't think it's going to take anybody 2.5 hours to do the exam. Again, it's written for 60 minutes for a 75-minute class. So in any event, when you're ready, you hit take the quiz, all right? And it will take you to a question. It'll just be one question, but it's going to have a Dropbox link here. And there's going to be different versions, but this will be the one for you. This will be the exam for you. And again, I've put those same instructions right here, all right? So you click this, and it says you're about to navigate away from this page. That's fine. We can always come back to re-upload it. It's not a lockdown browser where it's going to get mad at you for leaving Canvas. That timer is running, and you can always come back and re-upload the file when you're done, all right? So here is a practice exam, all right? So what you'll want to do is download this. Now, I'm in my own Dropbox because I'm signed in. But for you, up here, there will be a download link for this file. So I think I have to go somewhere special to get it. But over here, I can get download. So I'm going to download this PDF. And it goes into my download folder. You'll know wherever your download folder is. And let me get a clean screen here. I've got too many different hot corners and whatever going on here. So just get a clean, where's my, come on, there we go. All right, so I've got it downloaded. I'm gonna pull out that practice exam from my downloads folder, open it, and then I'm gonna decide whatever way I want to take this exam, all right? For me, you know, I'm a Gen Xer, so we got half our life was analog, half is digital. I still would probably print this out and handwrite it, all right? And then scan it and re-upload it, all right? But you don't have to. You can open this with Google Docs, and it will let you edit and put your answers right in here. The other thing that I want you to practice before you upload this practice is drawing, because there are going to be graphs or math that you might want to just hand draw. So I want you to practice both text, whether you type it or write it, and graphs, which you'll almost certainly draw. Now, you're welcome to do the graphs in a computer program if you've got those skills. Some of you may already, you know, you're a whiz in Microsoft Paint or whatever is an easy drawing program. So you're welcome to do that. As long as it's your graph that you draw, that's fine. But most of you are probably just going to want to draw it, shoot a picture with your phone, and throw it into here, all right? You can do that in a Word doc. You can do it in whatever you want, all right? So once I've got this all prepared the way I want it, let me show you one version of that. Let me just do that. And those of you who just want to get to the problems, I'll try to put a timestamp down below in YouTube, and you can just click and jump to the review for the problems for the exam. But those of you here live with me, or those of you who want, we're going to walk through one way of doing this, and I'm going to show you going through Google Docs. So I'm going to do Google Docs. I'm just going to Google that. All that is a launcher I have for launching Google searches fast. I didn't do anything special there. And I'm going to go to Google Docs. My dog is playing with a squeaky toy right outside my door, so that's what that sound is. He likes to come in here when I'm talking for some reason and sit on the chair behind me. Let's see. And I'm going to do a blank Google Doc. I think that's how you do this. And then I'm going to do File, Open, and I'm going to do Upload. And you can drag the PDF, the exam here, or you can just hit Select. I'm going to hit Select, and I'm going to go to my desktop where I put that. Let's see, the most recently added thing is the practice exam. Let me hit Choose. And what it does with Google is it first uploads it to your Google Drive, which is a little bit annoying because I was in Google Docs and I wanted to open it. And it instead, when I went to open this PDF, it took me to my Google Drive. So now, though, I can go back to Google Docs, and I can do File, Open, and I can do from my Drive, and it's usually the most recent file that you just did. Actually, I don't see it here. So maybe I didn't do something right. Oh, there it is. Yeah, I had to just go Show Me All Files. All right. And there is the practice exam. Now, if I open this, it's going to convert it into something. Oh, it did the same thing. Well, this worked the last time I did it. Let me try again. This is why I've given you that 2.5 hours, because some things like this may come up. Let's see. Open PDF. And instead it's going to over here. So what am I doing wrong here? Oh, open with, it's right there above it. I missed it. So, all right, so scratch some of that I just messed up, but I'm gonna leave that in. I'm not gonna edit that out when I go to upload this, because I want you to see I've budgeted time in case things don't go exactly right for you. So you go up here and you go open with, and then Google Docs. Yeah, sometimes Google frustrates me to no end. They make it all pretty and shiny, but the user experience is not always great. It should have just worked. It should have said file open PDF, and it should have opened it because they have that ability, obviously. Anyways, so what it does is it opens it and it converts it to text. Now, there is a danger that some things will get mangled. So hold on to that original PDF that you downloaded, because some stuff in this conversion may have gotten mangled. But for you, you're going to use this to submit your answers. So what I would encourage you to do is change the color of the text. Let's see, go right here and just make it like a dark blue. And it says, what is your favorite book, movie, or album? So my favorite movie is the Big Lebowski, Bowski. I don't know if I spelled that right or not. So there's my favorite movie, The Big Lebowski, and I'm going to just color it dark blue just to make it really clear. Might even italicize it that this is the answer. You don't have to do that. As long as you set it off from the question, it'll be fine. All right. Again, there's so few of you in here, and I don't know why it's doing that weird formatting. That's just one of the weird things that happens when you go from PDF back to a word processing program. All right, and then down here it says draw a picture of a dragon. This is supposed to be on page 2 here. Draw a picture of a dragon. It can be a stick figure, whatever. Let's see, do they let you draw here right in Google Docs? I don't know if they do. I don't use Google Docs, and I don't have my drawing program. Let's see, insert drawing. Here we go. New. Look at that. You can draw right into Google Docs. That may or may not be fun. I don't know. I don't see like a paintbrush, so no. So what I'm going to do instead, yeah, there's no paintbrush or anything. So instead of trying to draw a dragon like that, again, most of you probably won't do it that way. I'm going to draw one real quick on a piece of paper. I'm going to shoot a picture with my phone and put it into the Google Docs. And again, some of you are bored with this, and so I'm sorry, but I've learned I can't assume that all of you are super whizzes at this stuff. So I took a picture with my phone, and now I'm going to go to my Google Drive. You can either go to the Google Drive through a browser, or you can go to it through the app, or you can send it to your computer and do it that way. If this was just me and I was in my normal workflow, I would use what's called AirDrop, which you can go from one Apple device to another, dropping documents, images, any kind of files actually. But not everyone has that. So what I'm doing is I'm going to my Google Drive, and this is quite slow. So I am going to just do AirDrop, and I'll show you how to put it in the Google Drive on the computer. Again, there's a million ways to do this stuff. Most of you guys probably are better at it than I am. And this, again, is what that 2 hours extra is for, to facilitate all these little steps that if you were just in the class, you would already just draw the thing and then turn it in. But because we are remote, I have to add a little bit of consideration that it takes a little bit more time to do all these steps. All right, so I'm gonna send that dragon to my computer. You can email it to yourself. You can text it to yourself if you get your text on both devices. Again, I'm using AirDrop for mine. Now I have a dragon. Oh, I dropped him. There he is, sideways dragon. We'll get him right side up here in a second, I think. if it'll let me. Doesn't want to let me move it. No, I don't want Grammarly turned on. I want to let me move it. I guess, do I have to close this? Oh, let me move it. I want to let me move, because Google Docs is not always the greatest. That's fun. All right, I guess I have to rotate it first. So and get him right side up. There we go. And now if I close this, can I move it? Why can't I move it? Dear Lord. Oh, I have to click it twice to move it. And then it takes this frame away. That makes sense, doesn't it? Wow, Google Docs, you're terrible. I don't understand this at all. Oh, what a terrible program. Yeah, that is awful. Those of you who use Google Docs all the time probably know what I'm doing wrong here. I have no idea why it won't let me put it where I want. Unbelievable. This is why I don't use word processors. I use LaTeX, because LaTeX lets you put things where you want them. It does not override your ability to do what you want. Yeah, you literally just can't pick up an image and put it where you want it in Google Docs, I guess. Man. No, you have to pick that. It still won't let. Oh, you have to pick an option. Oh, that's interesting. All right, so the default is not to let you put it wherever you want. You have to pick this option. So that's nice of them, because you would totally expect the other way. But I guess it's for if you want to do the fancy thing where the text goes around the image like it's a newspaper article or something like that. So, and now it's messing it up again. All right, so now I got it. So I'm going to use my full 2.5 hours here. So I'm done. So make sure you save so that you've got it, and auto saves on Google Docs. Then I am going to share. And no, I'm not going to share. Share does not mean that. Google is inconsistent with what share means. I want to download as a PDF. There we go. And there it goes into my downloads folder. So now I'm going to go back to the exam right here. And this is where it won't work for me, but it will work for you, because the professor, even in student view, can't actually upload it. But I'm going to show you. You click upload file, then let's see where the one is. Make sure you have the one that you wrote on. Oh no, it's in downloads, that's right. I probably should have renamed it so I didn't make a mistake of uploading the wrong one. So here it is in downloads, and I'm going to just rename it now. Oh, I selected it, sorry. Anyways, and there it goes. It's been successfully uploaded. There is the file. You know, what I'm actually going to do is I'm going to put on the real exam a second question that's a just in case. Like, what if you accidentally upload the original exam and you realize it? I'm going to put question 2, here actually is my PDF. So just in case, because it doesn't look like it lets you, let me see if I refresh this, does it let me redo that? It doesn't. Now that could just be something because I'm the professor and I've been told that the student view doesn't work the same way. But in any event, I'll add a backup just in case, okay, on the real exam. When you're done, then you hit submit quiz, all right, and now you're done, all right. Now it doesn't show that I uploaded a PDF. That doesn't work for the professor's student account, but it should work for you. If one of you would be so kind as whenever you do this, if it does mess up, please let me know. But I've been told, I've read through a lot of help files, a lot of Canvas community pages, that this should work just fine. Has anyone done it yet? Walk through the steps. And again, you may not do it in Google Docs. You may just print that thing out, draw on it, scan it, and then upload the PDF, right? That's probably going to be less frustrating. But some of you are great. You're fully digital. You'd rather just type it. And it's certainly easier for me to read it when you type it. My handwriting's terrible too. You saw with my dragon. In any event, you can prepare it however you want, but you have to submit it as a PDF at the end. All right. And then I will grade that. So let me see. Let me get out of the student view here. And just see. Okay, somebody looked at it at least, but I'm not sure if they actually did a submission. That's fine too. I would practice doing all the steps. It'll just reduce your anxiety, especially if you start running short on time. Okay, now that's the technical stuff. Let me stop for a second and see if anybody has questions about that administrative computer tech kind of parts of the exam, and feel free to comment how terrible Google Docs is. That was horrible. I used it the other day. We were buying a car, and so I just wanted a simple calculation, so I didn't want to fire up R, and turns out I should have, and it was just a nightmare because nothing does what you expect it to do. It's better than Excel, but only a little bit. Anyways, any questions? The only other thing I'll say about the exam is if you want to schedule your 2.5 hours where it overlaps with these two time windows, right? Let me zoom that up. So I will be on Zoom, I'll have it running while I'm working on whatever else it is I'm working on. You know, I won't have the sound on or probably the video, but it'll be that little picture of me, but I'll be here. So if you want to have your 2.5 hours overlap these windows, you can be sure that if you have a question, you can get it answered immediately. And what I've also said is, as long as I'm at my computer here working that day, I'll go ahead and turn Zoom on. But I'm guaranteeing you that I will be here for these hours. I've blocked that off in my schedule. I have some other Zooms I have to do during the day, so I won't be able to be on for those. But for these two windows of an hour, I guarantee you I will be there, and you can pop on and get my attention, and I'll be able to answer your question immediately. So if you're able to do that, I know not everyone will be able to, but if you are, that's the fastest way to get a question. Is the exam supposed to be submitted before the 2.5 hours are up? Yes, the exam, you have to go back and submit the PDF before the 2.5 hours are up. It's not an all-day affair. You can start it at any point during the day, but you only have 2.5 hours, okay? And I will be available those hours. Let me zoom this back down. It doesn't, oh, I wasn't selecting the right window. There we go. So please practice that. It'll reduce your anxiety a lot, I think. I tried this a bunch of different ways in the spring, and it's a lot, there's no great way to do it. So what I thought I would do, especially since the class is so small, is to give you the maximum freedom to do it however you want, just knowing that at the end of everything, you've got to turn it back into a PDF, all right? And so there's YouTube videos on how to take a set of images and make them a PDF. And that 2.5 hours gives you the time to go and look at that if you need to. This is open book, it's open note. The only thing you can't do is work with other people in the class. And there will be multiple versions. of the exam. Please just work only you. If you have questions, ask me. But beyond that, you can use the internet, you can use the book, you can use the slides, you can use the screencast, whatever it is you need to answer the questions, all right? But don't not study, all right? Because I had some people do this in the spring. I could tell they just didn't study and thought they would just look everything up, and they ran out of time. It's not going to be that a kind of exam where you can approach this stuff not being familiar with it, all right? Any more questions about the exam, like administrative part, before I move to the content? Okay, so I will now start to talk about the actual content of the exam. So let me get too many windows going. How do I, there we go. It's the practice exam. Where's the, there we go. It's all behind here. You got it. Okay, so first, homework 1. I got the solutions here. Let me blow these up as big as I can. Never know if people are watching on like tiny phones or screens or what. So here is homework 1, and I'll go through all of these since the solutions are up. So when we say rational choice in political science or in economics, what conditions must a person's preferences meet in order for us to consider them rational? All right. So in this class, we've got a pretty broad definition. In order for them to be rational, their preferences have to be complete and transitive. All right. Those of you who've taken microeconomics 302 intermediate know that there's a couple other little assumptions we have, but for this class, we don't really need them. They're overly technical for our purposes. So basically, a person's preferences are complete, meaning that if you give them a set of things, they can tell you in what order they like them, or that they like them all the same. Weak and strong preferences are allowed, but that they don't just go, I don't know, right? They are able to tell you how they like those things. I like Coke more than Dr. Pepper more than Pepsi, right? I like Coke the same as Dr. Pepper and both more than Pepsi. I like them all the same. Any sort of ordering meets the definition of complete. What is not complete is when someone says, here's Coke, Dr. Pepper, and Pepsi, and they just go, I can't tell you. Not that they're indifferent, they just say, I can't tell you, all right? That is all completeness is. So it's a very easy assumption. The other one is transitivity. This one's a little more restrictive. It's basically the same thing as mathematical transitivity, right? In math, 3 is bigger than 2, 2 is bigger than 1, 3 is bigger than 1. Numbers are transitive, right? So in the preferences world, if I like Coke more than Dr. Pepper, and then Dr. Pepper more than Pepsi, it must be the case I like Coke more than Pepsi. All right, that's transitivity. So rational agents have preferences that meet those two conditions, all right? And they take actions in accordance with those preferences. They don't act against their own preferences, all right? The next one says, in general, what is the concept we use to think about wants in this framework? And what is the mathematical representation? So wants are, we don't talk about they want this, they want that in this class. We talk about what they prefer, right? I prefer Coke to Dr. Pepper. So preferences are the way we talk about what people want in this rational choice paradigm, all right? And then mathematically, we use utility functions, right? Where's my arrow? I lost it, there it is. We use utility functions, and some people say that we use this preference notation. That's fine too. But what I was looking for is that wants are represented by preferences, operationalized by preferences, represented by preferences, and then mathematically we use utility functions. My utility for Coke is greater than my utility for Dr. Pepper is greater than my utility for Pepsi. And I could even give numbers. If I had a utility function, I could plug in 1 unit of Coke, 1 unit of Pepsi, 1 unit of Dr. Pepper, 1 unit of Pepsi, and it would spit out numbers that would abide by that ranking. So Coke would be 100, Dr. Pepper would be 97, and Pepsi would be negative infinity, right? Because it's sweetened battery acid, all right? So that would be my utility for that, all right? So for the most part, again, those of you that have had intermediate micro, you've seen more sophisticated utility functions where we actually had like, you know, x to the 1/2 power times y to the 1/2 power, and you would put in the units of x and y, Coke and Pepsi. So Coke to the 1/2 power times the amount of Pepsi to the 1/2 power, and you plug it in. For the most part in this class, I'm just going to give you the utility numbers, all right? We're not going to do a lot of that utility calculation that you saw in some other classes. If you haven't had that class, good for you. You don't have to worry because we're not going to get into that technical aspect. So in this class, for the most part, just like I did in this homework, I'm going to give you the agent's utility, all right? In general, how do we operationalize beliefs in this framework, and what is the mathematical representation we use to operationalize their beliefs? So we use probability statements. So the probability of this happening is 1/3, right? That's someone's belief, right? It's they didn't get that probability from God or from some sort of simulation that simulated all possible outcomes. It's kind of their subjective probability. I think if I study 1 more hour for this exam, my grade will go up by a point. How sure are you about that? Well, I'm like 90% sure. So 0.9 probability. So probability statements are how we represent people's beliefs. And then we use mathematically probability functions. The probability that action A, that doing A will lead to outcome X is some number, right? So we end up with wants being a number, their utility number, their utils, and we end up with preferences being a probability function, also a number. That allows us to do an expected utility calculation. We take the probability that an action leads to an outcome, and we multiply it by the utility the agent gets for that outcome. And then we do that for all the possible outcomes for a given action, and we get the expected utility. And that's exactly what the next problem is about, all right? And if you're curious where I got this from, let me just do, I'll put a link to this up in the, oh, I can't find it. Oh, the Battle of Strongbadia, let's see. This is a web comic that was very popular when I was in grad school with the undergrads. Actually, it's 2 guys that went to UGA when I was there. I did not know them at all. UGA is a huge school, but they were, did UGA. Where does it put the appearance? There we go. Strongbadia email army. And I'll put a link down below for this because I can't play it through Zoom. It chops it up. The encoding is no good, but oh, that's on the Flash site. I don't want that. I want it on YouTube. There it is. So I'll put a link to this down below on YouTube, so you can watch it. It's not the exact story that I modeled in the assignment, but it's sort of where I got, you know, the invasion of Strongbadia. So, Colonel Homestar Runner of Free Country USA is trying to decide if he wants to lead his Homestar Army to invade Strongbadia. If he stays home and plays the Wii with third-style Private Benedetto, he believes he's got a 1 in 3 chance of the good times being over. It gives him a utility of 0. And he gets a 2 in 3 chance of winning a gold bull. All right, that gives him a utility of 100. All right. If he chooses to attack Strongbadia, there's a 33% chance he will be victorious, and he will no longer have to play second fiddle to a 2-bit Wrestleman and his yellow dog. All right. He values that utility at 300. If he loses the battle, he will have to hug a tree for several hours, which he values at -75. using the proper notation from class, write out the following. So first, I give a little bit of notation here. All right, and I put an example, also put an example of problem for this up on Canvas. So if you want to see another version of this kind of problem, go download that one on Canvas. Let's see if I have that handy here. Man, I got too many windows open. Canvas, if you go to the modules page, right here, expected utility calculation. I typed it up in LaTeX, so it's all typed out and all the way down to the final calculation. So that's another example if you want to review that one. All right, so here is, so I'm going to say that the outcomes are not playing second fiddle, winning a gold bowl, the good times being over, and hugging a tree. And according to the utility, right, he gets 300 for no longer having to play second fiddle to a 2-bit wrestle man and his yellow dog. So that's the highest. The second highest utility was 100. That was winning the gold bowl. The third highest utility was 0, and that was the good times being over. And the worst thing for him was negative 75 utils for having to hug a tree. So his preference ordering in preference notation is for home star, and that's what the little H means on this strictly preferred notation. So Homestar strictly prefers not having to play second fiddle, to winning a gold bowl, to the good times being over, to having to hug a tree. It's a strict preference, all right? And then here are the utilities. The utility of Homestar for not having to play second fiddle is 300. The utility of Homestar of winning a gold bowl is 100. The utility of Homestar for the good times being over is 0. And the utility for Homestar of having to hug a tree is negative 75. What are his possible actions? Well, he can play the Wii, stay home, or he can attack Strongbadia. And I'm going to abbreviate that Wii as WII and attack Strongbadia as AS. So what are the probabilities that each action will lead to each outcome? Now the key here is that you should have, for each probability, you should have a probability statement for every possible outcome, all right? These are the outcomes, so 1, 2, 3, 4. So for each of these actions, there should be 4 probability statements, all right? Trust me, do it this way. It seems like strange because notice, there's no way he can win the battle if he stays home, right? But if you do it this way systematically, you won't leave something out. So I should have the number of actions times the number of outcomes. I should have that many probability statements. So here, my number of actions is 2. My number of outcomes is 4. So I should have overall 8 probability statements. And it won't let me select it the way I want. But indeed, right here, you can see, oh, annotate. That might help. Look at that. 8 probability statements. All right. So where did I get those? All right. So I got those from the description. So what is the probability that playing the Wii leads to winning the battle and not having to play second fiddle to a 2-bit wrestle man and his yellow dog? Well, it's 0, right? Notice in the description, staying home and playing the Wii cannot lead to doing that. So the probability of that outcome, that action leading to this outcome is 0. The same thing is true for having to hug a tree. He had to hug the tree when he lost the battle. Well, if he stays home and plays the Wii, takes that action, the probability of that action leading to that outcome is 0. All right? So the other 2 things were, if he plays the Wii, what is the probability he wins a gold bowl? Right here, winning the gold bowl is a 2 in 3 chance. Now 2 in 3 chance, I can't do math on. I have to turn that into a probability. 2 in 3 chance, that's a 2 over 3 chance, 2/3 probability. And then the good times being over, well, the probability that playing the Wii leads to the good times being over. Also in the description, 1 in 3 chance, 1 over 3, or a probability of 1/3. For a given action, all of the probabilities must sum to 1. That's a good check, this step, to know that you've got everything. All right? So 2/3 plus 1/3 is 1. So if he plays the Wii, something will happen. That's what a probability total of 1 means, right? If we added up the probabilities and it was 5/8, that means there's a 2/8 chance nothing will happen, all right? But here, something will happen if he plays the Wii. He will either win the Golden Bowl with the probability of 2/3, or he will, the good times will be over, probability 1/3. What about if he attacks Strongbadia? Well, notice, if he attacks Strongbadia, he can't win the Gold Bowl. And if he attacks Strongbadia, the good times can't be over. Those were only outcomes that were possible if he first plays the Wii. So both of those have a probability of 0. So what is the probability that if he attacks Strongbadia, he will win and not have to play second fiddle to a 2-bit WrestleMan and his yellow dog? It's a 33% chance. Again, 33% I can't use in a math equation. I need to convert it to a probability. Most of us are really familiar with how to do that, right? A probability times 100 is the percentage. So you divide this by 100, get rid of the percent sign. It's 0.33, or I'm doing everything in fractions because fractions are your friends, decimals are the enemy. So the probability of attacking Strongbadia leading to victory is 1/3. And of course, by the rule that everything has to add to 1, I already know this is 2/3, right? But in this case, I gave it to you. Actually, I didn't. I wanted you to have to figure that one out. That was part of the question. So I didn't tell you the chances that he loses, but you have to know that the probabilities add up to 1, all right? So the probability that attacking Strongbadia leads to having to hug a tree that he loses is 2/3. So now, what should he do? We have to combine the probabilities with the utilities, right? Because a utility could be really, really high, right? There's a chance I will win the lottery, right? But the probability is really, really low. So when I'm trying to decide, do I want to spend $1 or not, I have to take that probability into account, all right? So that's what expected value or expected utility calculations are about. They're about giving you, given the chances something happens, times the value of that outcome, or in our case, we call that more precisely utility of that happening. What is the expected utility if I do that action, all right? And the formula for that is you take the probability that an action leads to an outcome times the utility for that outcome. The probability that that same action leads to the different outcome times the utility for that outcome. And you just do that for every action outcome probability times the utility that there is for that decision. Sometimes this will be a small equation, sometimes it will be a large equation, all right? And again, there's another example of this with the Claire McCaskill example from the book. I made it a little more precise than the book did. In the reading, I gave some hard numbers, so it's easier to do the calculation, but I put that in there, okay? So let's do this for Strongbat. I'm sorry, for Homestar. Homestar is the one attacking. So here's the expected utility of playing the Wii. It's the probability that playing the Wii leads to not playing second fiddle. That's right here, 0. So this is the reason I want you to write all of these out, because now it's just plug and chug. You're just plugging in the things you already found. So the probability of that is 0 right here. And the utility for that action is 300. So it's the best. It's the best possible thing, but there's no chance it will happen if he plays the Wii. All right. So 0 times 300, when you do this out, is going to be 0 for this term in the expected utility. What about if he plays the Wii and winning a gold bowl? Well, we said above that there's a 2/3 chance of that. And we said above that he gets 100 utils for that. So for this term of the expected utility, that beeping, my house isn't about to explode. I live right next to the post office. That's a big post office truck backing up. And my window is open a little bit. So 2/3 times 100 will be that term, all right? The next one is, what are the chances that playing a Wii lead to the good times being over times the utility for the good times being over? Well, that's 1/3 is the probability, and the utility for the good times being over is 0. He got no utility for that. Then the last two, let's see, where was I? Oh, I did this one. The next term is the probability that playing the Wii leads to having to hug a tree. Well, the probability that playing the Wii leads to hugging a tree is 0, and his utility for hugging the Wii is -75, so this term is 0 times -75. So notice, this term is 0, this term is 0, this term is 0. That happens a lot in these calculations. Either the utility term is 0, or the probability is 0. So all we end up with is 2/3 times 100, so we end up with 66.66% repeating. I'm sorry, 66.66 repeating utils. This is, the units here are utils. They are Homestar's utils. So how much should he value playing the Wii? His expectation, if he plays the Wii, is that he'll get 66.66 utils. It's a weird name for the units, but that's what we call them, right? And we don't take them super precisely, like this is one util plus another. All we're gonna do is say which is more, and he should do that one. It's ordinal at the end of the day. Now for attacking Strongbadia, the probability that attacking Strongbadia leads to victory and not playing second fiddle times the utility. Well, that's 1/3 is this probability. Oh, it won't let me select it for some reason. And then the utility is 300 right here. Do that for each term, all the way down, and you end up with an expected utility for Homestar, if he attacks Strongbadia, is 50. 66.6 repeating is bigger than 50, so this should be his choice. All right. Any questions on that one? Okay. The next one is just a question. This is from the Clark and Primo reading, or the screencast, or the slides that I did. What are the 5 different purposes of a social science model? Foundational models, structural models, generative models, explicative models, and predictive models. And I define those here and in the screencast and in their article. What is the general criteria we should use to determine if a model is a good model or a bad model? One of the things we said is we can't judge a model as being good or bad by if it's true, because all models are false, right? All models are lies. But some models are useful. And I gave you the quote by George Box in the screencast. He was talking about statistical models, but all models are wrong, but some models are useful. So really, we're going to judge whether a model is good or bad by, is the model useful? Is it useful specifically for the purpose for which it was designed? You can't judge a model that was built for one purpose because it's bad at another purpose. That's like judging a map that you draw from your house to the nearest gas station and me saying, I can't get to Pittsburgh with this map, your map is crap, right? That's not fair, right? You didn't draw the map to get me to Pittsburgh. You would have drawn a different map. You would have included different details, right? You would have abstracted away from some of the details you put in the map to get to the gas station. The same is true of models in social science and in the hard sciences, all right? And then how can a model with false assumptions be useful to a social science? Well, all models have false assumptions, all right? There's no such thing as a true model. The usefulness of a model can't be judged by the accuracy of its assumptions. You can't test, is this model accurate? You can test, is this model useful though? And the way you do that is when you get a model and it generates a hypothesis, you can go out and get real data and test, is that model useful for that hypothesis? That is perfectly fair game, all right? But what's not fair game is to say, you assumed in this model that all pictures of picnic tables represented picnic areas. That was your assumption. Well, I drove over there and there's no giant picnic table because you put a giant picnic table. That's not how you judge the model. But if you drive up there to where the giant picnic table is and there's no picnic area, that's a perfectly fair empirical way to judge if the model is useful, if the map is useful. So it's not that any model is fine, and it's not that all models are equally useful, right? But you can't just say, we assumed people are rational. Here's a case where somebody is intransitive. Therefore, all models that assume rationality are crap. It's just not a philosophically valid way to judge a model, all right? We judge models by if they're useful for the purpose for which they're designed. Do the hypotheses they generate, do we find those generally in the real world? All right, those starting axioms in a model, those assumptions, they can be whatever the modeler needs them to be, all right? Now, someone may come up with a better model with more realistic assumptions that is equally or more useful, and that's a better model, no doubt. But just because a model has a false assumption, it does not in any way philosophically justify rejecting a model. And this happens all the time to social scientists. The hard scientists tend to get away with it a little more, right? Assume a vacuum, assume a frictionless surface, right? And they can generate hypotheses, right? But in social science, we often have a harder time convincing people, all right? And a lot of it is our fault as people who do formal and rational models, because a lot of people who do this kind of modeling do not understand this philosophy of science. It doesn't get taught. It didn't get taught to me in grad school. I picked it up through Clark and Primo's book that they put out while I was in grad school in political science, actually. Political scientists, sorry, my econ folks, they tend to be better at this stuff because they have more people in their discipline who critique their modeling. Serious folks who are smart, who critique their modeling. In econ, we're all basically on the same page for the most part in terms of using mathematical models, and usually rational models, not always. So we don't face the criticism, so we don't study the philosophy of science behind it. But in political science, they do. They have some very smart, sharp people who critique using rational choice models. And that's why Clark and Primo wrote this book. You guys got the article version. Okay, that's it for this homework. For the next homework, I'm just gonna do examples of the two mathematical problems, all right? So if anybody has questions about number 1 or number 2 or 4 or 5 or 6, I'll take those at the end. Those of you on YouTube, I'll try to put another timestamp in so you can jump to those if you already have the math ones figured out. But I bet this is what most of you came here for today, is to see some examples of number 3 and number 7. So let me load up the examples I prepared beforehand. If I can find them. Too many screens. Is this it? Yeah, this is it. All right. So this is an example of number 3. Which is right here. Let me zoom it up, blow it up, whatever. All right, number 3. So the one you have to do is if 4 people, 4 choices, and of all of the possible societies, all of the possible preference orderings that those 4 people could have, right? 41,472 of those would produce a cycle. I'm not asking you to calculate this number, by the way. I will give you this number. But of all the possible societies that 4 people and 4 choices could generate, 41,472 of them would cycle. What is the probability that there would be a Condorcet vote cycle? All right, I'm not going to do that one, but I'm going to do one like it because you have to do that one. So this is, I just went through and copied the slides and sort of put a different example in. But what are we concerned about here? So in the slides, I basically said, let's assume there are 3 people and 3 alternatives. This is very common in social choice, in voting models. We start with examples, 3 people, 3 alternatives. Anything less than 3 people and 3 alternatives, it's not usually that interesting because there's not a lot that can possibly happen. But with 3 people and 3 alternatives, things get crazy. All right, and then of course, the more people and alternatives you add, the crazier things get. So with 3 people and 3 alternatives, this is one possible society, right? Person 1 prefers A to B to C, person 2 prefers C to A to B, and person 3 prefers B to C to A, strictly, all right? That's one society. And there can be, those people, any one person in the society could pull any of these 13 preference orderings out. So with 3 people that can pick any of these, there's a lot of possible societies, quote unquote, that we could see, right? There's one society where everybody picks this first ordering. Person A is ABC, person B is ABC, and person C is ABC. That's one possible society, all right? Sometimes it's called a preference profile, all right? And what we're gonna do for these calculations is we're gonna restrict ourselves just to the strict orderings. So we're not gonna worry about these for these probability calculations, all right? So just if I have 3 people and 3 alternatives, there are 216 possible societies, all right? You don't have to know how to calculate that. How many of those 216 would cycle? Again, you don't have to know how to calculate that. I'm going to give you that. As it turns out, it's 204 of them. All right. So given that 204 of the societies would produce a cycle, a Condorcet cycle, given 3 alternatives and 3 people, what is the probability that any random society that I draw out of a hat of strict preferences would give me a Condorcet vote cycle? That's what this question is about, all right? So for that one, it's in the slides. I'm not gonna do that one again, but what I'm gonna do is I'm gonna do a made-up example, all right? So just to remind you, here is the formula. The probability that a vote cycle, the probability that I see a Condorcet vote cycle, given M alternatives and N people, is the number of cycling societies over M factorial, the number of alternatives, factorial, to the nth power. Factorial just means whatever M is, you do M times M minus 1 times M minus 2 times M minus 3 until you get to 1. All right? And again, I'm going to show you an example. There's already one in the screencast and the slides, and I'm going to show you one here also. So here's the one I'm going to show you. We're going to do 4 people, 5 alternatives, or 5 choices. All right. So again, you don't have to know how to calculate this, but I'm going to tell you that there are 823,040 societies that could produce a cycle. All right. What is, and how many societies are there overall? Let's see, you do, I'd have to do a lot of math to figure that out. So never mind. But what I'm going to give you on the exam is just like in the homework. I'm going to give you the number that would cycle, the number of people, and the number of alternatives, and you have to do the calculation. So how do we do that? What is the probability that a randomly chosen group of 6 would produce a cycle? All right, so I'm going to get my formula from right here, and I'm going to plug everything in. And that's what I do here. All right, so I said the number of cycling societies is 28,823,040. The number of alternatives is M, which is 5. The number of people is N, which is 4. So it's M factorial to the 4th power. All right, and this parentheses is key here. You don't do the exponent until you've done the factorial. All right, so we don't always remember our order of operations for things like factorials because they don't come up a whole lot. So that's why I put this parentheses here to let you know, do this multiplication before you take it to the nth power. All right. So what is 5 factorial? Well, it's just 5 times 4 times 3 times 2 times 1. Not times 0, right? That would wipe everything out if we had the times 0. So a factorial is just whatever number times that number minus 1, times that number minus 2, times that number minus 3, etc., until you get to 1. That's all a factorial is, okay? So 5 times 4 times 3 times 2 times 1 is 120. And again, I do the factorial before I do the exponent. So it's 120 to the 4th power. That is 207,000. Oh, that can't be right. 207 million, sorry. 360,000 is the bottom, all right? Oh, that's actually the number of societies. There we go. So that's the number of societies. So how do I now find out the probability? Well, it's the probability, it's the number of societies that cycle over the total number of societies, which we found with m factorial to the n. Again, you just have to know this formula. That's all you have to know, and then how to plug everything in. I will always give you this one. That is, you're never going to have to calculate that. It's actually a little bit complicated. So don't worry about that. That will be given just like it was on the homework, but you do have to know this formula. You do have to know how to plug it in. Now, of course, it's open book. You can go look up the formula. All right. When I do this, I get 0.139. So the probability that with 5 alternatives and 4 people that I will get a Condorcet vote cycle from any random society of strict preferences is 0.13. All right. And in the book, in what is it, chapter 58, not chapter 58, page 58, in chapter 5, I think it is. No, it can't be chapter 5, chapter 4.
Pulling up, I have a quick question.
Oh, sorry, let me turn you up. Go ahead.
Do you want us to write out each one of those steps when we're doing it, or just the first 2 in the answer? Is that fine?
It is up to you, but I can give you more partial credit the more you show me. So in general, if you make a math mistake, let's say when you did this multiplication, you just messed it up. Like easy to do in a test when you're a little bit anxious or stressed out, right? But you do every other step correctly, I take off 1 point for a math mistake. Because you knew what you were doing, right? But if you don't show me all the steps, I can't judge that, right? So I encourage you to put as many as possible, all right? But it is up to you. What you can't do is just write 0.139, right? You have to show me some of the steps. And it'll say that in the instructions, that you have to show me your calculation. But how many steps you show is up to you. But the more you show, the more partial credit I can give you. So it's sort of an insurance policy for you to show me more. But yeah, I mean, I wouldn't necessarily expect you to do every single one of these. But again, for showing it to you guys, I put every step in there. Is that vague enough? I'm sorry that that's not super precise, but is that enough guidance?
It answered my question.
Okay, thank you for asking. All right, so here is a little chart that comes from Riker's book. It's called Liberalism Against Populism. How timely is that book right now? Liberalism here is liberalism in the general sense of the Enlightenment and the classical liberal philosophers and all liberalism. Generally, all of us in the United States, for the most part, are liberals, not in the modern US sense, certainly, not left liberal, but this is what the book is about. Liberalism, individual rights, equality under the law, those kind of things against populism, which is whatever the most people want triumphing. So that's what the book is about. But he has this table, and it doesn't do all the calculations out, but what you can see is as you get more alternatives, eventually the probability of a cycle goes to 1, all right? And if I did a little more of these, it's pretty quick. that it goes to 1, all right? But as I add more people, holding the number of alternatives constant, I don't always get certain cycling, right? If I have 3 people, I can have an infinity of alternatives, or let's just say 9 million alternatives, just to give a big number, and I still won't get certain, it won't be certain that I will get a Condorcet vote cycle. It's still only gonna have an 8% chance. But the moment you add a few more alternatives, that increases a lot. So given that it's so easy to get a cycle, right, the number of alternatives, what are the number of possible choices that the Bibb County government could make? It's almost infinite, the number of different things they could do, all right? It's certainly a big number, right? So what we do is we often constrain either the number of people who can vote, or by having a city council, that constrains the number of people who can vote, or we constrain the things we can vote over, right? We're only gonna vote city council. First, we constrain in by saying not everybody in Bibb County gets to vote on every single thing. We're gonna have a city council that votes on the budget for the city. And in fact, you don't have unlimited alternatives even over the budget. We're gonna say this is the new budget and the old budget is the status quo, and we're gonna vote on those 2 things, right? So often in order to get a coherent group choice, we either limit M, the number of things we're considering at any one moment, or N, the number of people who can vote over that particular issue. One of the things representative government does is it prevents vote cycles, right? Because representative government limits the number of people who are voting at any one time over any particular issue. We all can go vote, all of us who are voting eligible citizens can go vote for president, right? And when we go, there's like 4 people on the ballot, 5 people on the ballot, depending on your state. California, there's 27 people on the ballot. But really, only 2 of them are usually viable, right? So we vote on that limited choice set with a whole lot of people, right? In hopes that there's not a vote cycle underneath the hood, right? That would possibly have caused us to say, we like this president over that president over that president, and then we like the first one again, right? We don't like those things, that kind of group incoherence, right? Which very well may exist in the true preferences, right? If we were looking at every possible, let's just say every person who has ever declared for president in the US, not ran a viable campaign, not whatever, but they've just said, hey, I want to run for president. All right, let's put all of those people in a football stadium and we have to vote over it. We very well might get an intransitivity, right? So often to prevent this group incoherence in choice, because we got to make a decision, we will limit either the people voting or the things we're voting over, or both. All right? So that's sort of the more general takeaway from this probability calculation. All right. So it's more than just about being able to plug some numbers in. Any questions on that one? I'm going to get a little water here. Where's my, and I know that sounded like I was maybe like opening a beer or something, but it's just my Perrier. Just for the record, I still don't have tenure. They postponed all tenure decisions and all contracts for faculty until the middle of June, until they get the budget down and know what kind of situation Mercer's facing. We've been told we're in great shape compared to our peers at other schools, so I don't anticipate any big issues. But anyways, I just so it's just a little Perrier here on the video. All right, so hearing no questions, let me go back to screen share. I'll lose again all of my chat to bring it back up. Where's the chat? There's my participants, and there's my chat. Okay, so that's the probability vote cycle. The other mathematical one on here I guess I'll save that, is, where is that homework? Again, I got too many spaces within screens. Where did I do it? Oh, right here. The other more mathy one is you've got this group of individuals, and I give you their individual preferences. So Jeff here likes W strictly more than he likes X strictly, more than he likes Y strictly, more than he likes Z strictly. That's why it's got just this squiggle and not the preferred to with the weak inequality. We don't need those a whole lot. They don't come up a lot, but we do need them occasionally. But for this, I'm just going to give you strict preference orderings for 3 people. And then down here, I've said they voted. I'm not telling you how they voted, all right? I'm just telling you they voted. They used some sort of voting rule. And they got this as their pairwise group choices. So if they had voted X versus Y, they would choose X. This just means the group strictly prefers X to Y. If they had voted on Z versus X, they would have preferred Z. If they had voted on W versus X, the group would have strictly preferred W. W would win. That's another way to think of this category. After they vote, which one won if they were doing a pairwise vote. Y versus W, Y would win. The group strictly prefers it. Y versus Z, Y would win. The group strictly prefers it. And Z versus W, the group strictly prefers it. Then I'm asking you if these preferences violate any of Arrow's conditions. All right, either Pareto, R is rationality or transitivity, and D is dictator, right? One of the things you had to do in this is you had to state Arrow's impossibility theorem and define the 3 assumptions, right? And let me see if I can get those slides quickly. Right here. Right. So arrows, do I put them all on one side? I don't, but they are all here. So universal immiscibility means people can have whatever preferences they want. They can do, except for being intransitive, they can have whatever preferences they personally want, all right? They have to have complete intransitive preferences, but they can otherwise rank the alternatives however they want. Pareto optimality means for a voting rule, if everybody wants something, if everybody likes A over B, the voting rule can never return B. Independence from irrelevant alternatives. I'll kind of leave that one for the screencast for the full explanation. But basically, if we're ranking A, B, and C, and I say, all right, let's vote, and we vote against, let's vote on A and B, and we say we like A better than B. All right. Now I introduce a D, and I say it's, we're going to compare A, B, C, and D. Okay, everybody, let's vote on A and B again. Not D, but A and B again, and I get B over A now from the group choice. That is a violation of independence of irrelevant alternatives. And I am not going to ask you to check that one in this class. If we were all together doing this on a blackboard, face-to-face, where I could see the confusion in your eyes, if you got confused, I would make you test this one. But for this class, I am not going to make you have to check for independence of irrelevant alternatives. It's a little bit tricky. It's not crazy, but I think it's just too much to ask for everybody. But in other classes, I have when we're live. But you will have to check Pareto. All right, you're going to have to check unanimity. You are going to have to check non-dictatorship, the D assumption, and you're going to have to check rationality, which is basically that people can have whatever preferences they want as long as they are transitive or incomplete. So basically with R, we're looking for intransitivity. With P, we're looking for a situation where everybody likes one thing over another, But the voting rule, the group choice is the opposite. And with D, we're looking for a case where everybody else wants something, but one person, and the one person gets their way. All right. So let's see. I think I put in I tried to pull up another example because I'm not going to do the one from the homework. I think this is a different example. I hope it is. No, I made a mistake. Did I? Oh, I did. Okay, so what I will have to do is I will have to, let me write this down. I will have to video separately a checking arrows conditions example because I made a mistake and the one I prepared is the one on the homework. I thought it was a different one, but I don't want you to have to, those of you who did join live, I don't want to punish you by having to sit here while I find one and work it. That's crazy. So I will do one of those and put it on Canvas. So you will get an example of that. But again, so for transitivity, you're checking for if I string these group preferences together, does it ever make a loop? All right. So it's pretty easy to do. You just start with one of them. So X is preferred to Y. Find a Y and string it up here. So X is preferred to Y, and then is preferred to W. And keep going until you get them all and see if you run into a loop, right? A loop would be X would show up again in the train, right? X would be preferred to itself, in other words, strictly. That would be a violation. So you're checking to see if this group, if the voting rule produced that sort of violation. For Pareto, what you're checking for is there one thing, one of these pairs that they all prefer? They all agree that L is preferred to M. Then go and check that L better be preferred to M in the group pairwise. If not, you have violated Pareto. All right. So look for one of these combinations pairwise that they all agree on. There may be more than one, but for all of those, check then what the voting rule gave you for the group, and they should agree. If they don't agree, you violated Pareto or unanimity. And then the last one is dictator. For that one, you're looking for a case where two of them prefer one way and the other one prefers a different way. There's going to be several cases like that. So you want to write all those down, right? Let me see if I can find one just to give you an example. So let's see. I think I know where one is. Yeah, so let's look at X and Y. So for X and Y, John prefers X to Y, right here, right? Jeff prefers X to Y, but Maggie, she prefers Y to X. So we got a 2 against 1. If this was 4 or 5 people, it's always 1 against everybody else. So we have Maggie against everybody else. All right, Maggie and John and Jeff, by the way, are social choice theorists. Maggie and John are up at Emory. So Maggie here prefers something different. You want to find all those situations. Then you want to check for that situation, did the group choice go Maggie's way in the first example? Did it go the one person's way? If it did, you violated dictator. So let's just check that first one. X versus Y. X versus Y, there's Jeff. X versus Y, there's John. So 2, and here's Maggie, she's the 1. She prefers Y to X. So when I look at X versus Y, it better go everybody else's way and not the potential dictator's way. Okay? That's how you check. You need to check all the situations where it's 1 against everybody. And if the 1 gets their way in the group choice, that's a violation. Okay? And I will make up a different example and walk through all of that again. But I don't want to walk through this one because, again, it's the one for the homework. Any questions about that one or any of the others on homework 2? Okay. Any other questions about anything? I guess I can come back to video now. My bright monitor shining on me. Anybody else have questions? Is that the window shining? Oh, it's that.
Can you explain the agenda control?
Yeah, so agenda control is when somebody gets to pick the order we are voting over the alternatives. All right. So in one of those, take that Condorcet voting example that I put in. Did I close it? Hope it didn't. Let's see. It is right here. So let's see the society. They're going to vote over M things. Here, that's 3. So if one of these people gets to decide the order they're going to vote, first we're going to do A versus B, then B versus C, and then C versus A, right? That person has agenda control. They are setting the agenda. That's what agenda control is. Why is it important? Why would you want to be that person? Well, let's take this particular case. This particular case is a society that will have a Condorcet vote cycle. This group, using pairwise majority rule, prefers A to B, B to C, and C to A. So, if I am person 2, and person 2 gets to decide the order we're going to vote in, right? What are they going to do? Well, they're going to say, well, first let's vote on, let's see, how would you do this? Let's vote, B versus C, right? B would win, right, for this group. So person 2 says, we're going to vote B versus C, then we're going to vote A versus B, and then we're going to vote C versus A. That way, all the pairs are checked, okay? So person 2 says, let's do it. It's democracy. The group votes B versus A. Person 1 votes for B. Person 2 votes for A. Person 3 votes for B. B wins. No, wait, did I start with B versus A? Sorry, B versus A, right? B versus A. Person 1 prefers A. Person 2 prefers A. Person 3 prefers B. A wins, right? We already knew that because we have the group choice written here. All right, A won that pair. Now we're going to run A against C. All right. Wait, I should have started with C versus B because I need all combinations to run. So yeah, start with C versus, so let me start over. Person 2, this society, person 2 has the agenda power. Person 2 says, we're going to run all the pairs. We're going to go C versus B first. Then we're going to do B versus A. Then we're going to do A versus C. That way, every pair gets a run. So they run C versus B. B wins 2-1. They run A versus B. A wins 2-1. Then they run C versus A. C wins 2-1. The person says, we voted on every possible combination. C is the winner. We're not going to vote anymore. So having agenda control when there is a cycle is very, very powerful. And what do we know about the probability of cycles? For reasonable numbers of alternatives and reasonable number of voters, it's high. So being the person who gets to set the agenda is very powerful. In the House, United States House, the Speaker of the House decides the order they vote on amendments. They vote on amendments as pairwise votes. You vote the amendment versus not the amendment. Pairwise. Then at the end, they vote on the proposal that's been amended, the new bill, versus the existing law, pairwise. They get to decide largely the order of those votes. It gives them a tremendous amount of power in terms of deciding what the outcome is. So that's the consequence of agenda control. Questions about that? I never screen shared. You guys couldn't see what I was talking about. Sorry. I was trying to share this picture when I was talking all that time. This is the three people. So if you need to, take a quick screenshot of this and rewind the YouTube, but this is what I was talking about. If I can figure out how to put that on the screen in the YouTube editor, I will. I'm not quite that savvy with YouTube's editor. I usually edit things offline, but I will try to throw that example in so you can see it on screen as I'm talking. Sorry about that. It's one of the problems with Zoom. Don't always know what you're seeing. Other questions about anything? Okay, I will stop the recording and I will post this onto YouTube and then a link on Canvas. I will also give you guys an example of checking arrows with a different example so you can see an example of that. I'll do that as quickly as I can. I'm starting all that stuff right now. So it takes a while to film things, to save them, edit them, compile them, all of that. But I'll do it as quickly as possible so you guys can have that example to do that particular problem on the homework if you've been struggling with it. But hopefully what I described in the video here gave you some idea. All right. I will see you guys later. Send me an email if you have questions.